This is part 2 of the review for quiz 5.3 to 5.6. Problem number 8 on the review packet, which is page 421, number 34, says a mass suspended from a spring is pulled down a distance of 2 feet from its rest position, as shown in the figure. The mass is released at time t equals 0 and allowed to oscillate. If the mass returns to the position after 1 second, find an equation that describes the motion. So, since it's pulled down to start, this is going to be a cosine function. Now, notice that it was pulled down, which means that the equation is going to start with -2 as opposed to +2. They also told me that the graph returns to its position of being pulled down 2 feet after 1 second. So the period was 1 second. And in order to write the equation for this, we have to set that equal to 2 pi over omega, or 2 pi over k, whichever one you want to use. So omega is 2 pi. So here is our equation that describes the motion of the spring. Problem number 9 is from page 396, number 13 and 14. One of the things I'm going to ask you to do on the test is to graph one period of a sine and or cosine function. I will not be asking you to graph tangent, secant, cosecant, or cotangent. So number 13, g of x is equal to 3 plus 3 cosine of x. There are a couple of things you need to know, like you need to know that the amplitude is 3. You need to see that k is 1, so the period is 2 pi over k. And we also need to see this number. What that number does is it said that's the average. That means my middle line, the line that goes through the center of my graph, is at 3. The amplitude tells you how far above and below that middle line you go. So if you go 3 above that middle line, you're at 6. And if you go 3 below, you're at 0. Now I'm going to put the end of the period out here at the end. So if the end is 2 pi, the middle is pi, this is pi over 2, and this is 3 pi over 2. Since the graph is cosine, it's going to start at its maximum, because it's positive 3 in front of cosine. And then it's going to go to the middle, minimum, middle, maximum. And there's one period of 3 plus 3 cosine of x. Now let's go do this again. For number 14, g of x is equal to 4 minus 2 sine of x. Notice that the 4 is at the beginning, kind of like the 3 was at the beginning here. I could rewrite this as -2 sine x plus 4. Either way that I write it, that's that average. So when I draw my graph, my middle line is going to be here at 4. And then the amplitude tells me how far above and below that line I go. So if I go 2 above, I'm at 6. 2 below, I'm at 2. The period, again, is going to be 2 pi, because it's going to be 2 pi over 1. So 2 pi, 1 pi, half a pi, 3/2 pi. Since this is a sine graph, the sine graph starts on the average line. Then you have to decide if the graph goes up or down. It goes down because the amplitude actually has a negative in front of it, so it's going to go to its minimum, middle, maximum, middle. And there's one period of 4 minus 2 sine x. Number 10 is from page 396 as well, number 18 and 20. In these problems, they wanted you to find the amplitude and period and sketch the graph. So the amplitude in number 18 is 1. The period is 2 pi over k is 2, so it's 1 pi. Then when I go and graph this, there's no line or no value that moves my graph up or down, so it's going to oscillate about the x-axis. Since the period is 1 pi, I'm going to put 1 pi out here. So this is half a pi, a quarter pi, and 3/4 pi. Since the amplitude is 1, it just goes up to 1 and down to -1. It's a sine graph, so it starts on the middle line. And since it starts with a negative, it's going to go down first. Middle, up, middle. Let's look at problem 20. The amplitude in number 20 is 1/2, and the period is 2 pi over k is 4, which is pi over 2. So in order to graph this, I'm just going to call this 1/2 and this -1/2. The period is pi over 2, which means that this is pi over 4, this is pi over 8, and this is going to be 3 pi over 8. It's a cosine graph, so it's either going to start at its maximum or minimum. Since the amplitude starts with a positive, it starts with maximum. So maximum, middle, minimum, middle, maximum. And there's one period of 1/2 cosine of 4x. Number 11, page 405, number 53. When we worked on the 4 other trig functions, although I showed you what the graphs look like, just so you know, I said we weren't going to focus on the graph, so I'm not going to ask you to graph this on the test. However, I am going to ask you to find the period, the phase shift, and the interval that you would graph it on. We could graph one period on. Now remember that sine and cosine are the only functions that have amplitude, because they have a highest and lowest point on the graph. The other 4 trig functions, they go up and down forever, so they don't have amplitude. So the -2 in front of the tangent, it makes the graph narrower, and it reflects it over the x-axis, and that's all it does to it. So the period, remember for tangent, the period of tangent and cotangent is actually 1 pi. So we use 1 pi over k, and k is 2, so the period is pi over 2. To find the phase shift, all you have to do is take what's inside the parentheses, set it equal to 0, and solve for x. So 2x is equal to pi over 3. And then when you divide by 2, you get pi over 6. The interval on which we would graph one period would be the phase shift, is where we would start, and the period plus the phase shift is where we would end. So pi over 2 plus pi over 6, which is 3 pi over 6 plus pi over 6. That's 4 pi over 6, or 2 pi over 3. And that's the interval on which we would graph one period of -2 tangent of 2x minus pi over 3. Let's do this again for a cosecant function. The period for cosecant, because it's the reciprocal of sine, is 2 pi over k. So 2 pi over k is pi, is going to give me a period of 2. And then the phase shift is going to be pi x minus pi over 3 equals 0. So pi x is equal to pi over 3. And the pi's end up canceling, so you're really just left with x equals 1/3. For the interval on which we could graph one period, we would do 2, comma, not 2, let's try that again. It's always the phase shift, comma, the phase shift plus the period. And 1/3 plus 2 is going to be 7/3. And that's the interval on which we would graph one period of the cosecant graph. For number 13, page 384, 15, 16, I realize this came from section 5.2, but we did do this again, where we were finding exact values of trig functions, and people were still having some difficulties with it. There are 2 things that you need to know. One of them is what's the reference angle, because the reference angle is going to tell you what the answer is, or at least part of the answer. The other thing you have to know is what quadrant you're working in. because you have to know if the answer should be positive or negative. And that seems to be throwing some students. So I want to find the secant of 11 pi over 3. Remember that the secant is the reciprocal of cosine. So if you find the cosine of pi over 3, which is the cosine of 60, the cosine of 60 is 1/2. And since the cosine of 60 is 1/2, the secant is going to be 2 over 1. But before I determine that that's the final answer, I have to figure out if the answer should be positive or negative. And it depends on what quadrant you're in. Now, one way of doing it is to just kind of go around the circle. You can figure it out, or you can change 11 pi over 3 into degrees and subtract 360 until you get a coterminal angle. But you'll find out that 11 pi over 3 is in quadrant 4. And in quadrant 4, are cosines positive or negative? Cosines are positive, so the answer must be positive 2 over 1. Now let's find the cosecant of 11 pi over 3. We're still working in quadrant 4, and since cosecant is the reciprocal of sine, and sines are negative in quadrant 4, I already know the answer is going to be negative something. It's going to be negative whatever the reciprocal of the sine of pi over 3 is. Well, pi over 3 we said was 60, and the sine is the square root of 3 over 2. So the cosecant must be 2 over the square root of 3. And it needs to be negative because it's the reciprocal of sine, which is negative in quadrant 4. In part C, the secant of negative pi over 3. Guess what? Negative pi over 3 also in quadrant 4. So it must be the same answer as the secant of 11 pi over 3. So the answer must be 2. All right, let's do this again with 7 pi over 6. If you change 7 pi over 6 into degrees, you're going to find out that it's in quadrant 3. In quadrant 3, where all students take calculus, cosines are negative. So I know the answer is going to be negative something. Well, it's going to be negative whatever the cosine of pi over 6 is. Pi over 6 is 30. The cosine of 30 is the square root of 3 over 2. So the answer must be negative square root of 3 over 2. The secant of 7 pi over 6 has to be the reciprocal of the cosine of 7 pi over 6. Hey, I already found the cosine of 7 pi over 6. So all I have to do is flip that fraction. And the answer must be negative 2 over the square root of 3. 11 pi over 6 is in a different place. That's going to be in quadrant 4. The reason I know it's in quadrant 4 without actually changing it to degrees is because if you remember one full circle is 2 pi, 12 pi over 2 would be 2 pi. So 11 pi over 2 must be right before it in quadrant 4. In quadrant 4, tangents are negative. All I have to do is figure out what's the tangent of pi over 6 or 30 degrees. So the tangent of 30 degrees is 1 over the square root of 3, or you can tell me it's the square root of 3 over 3. I don't care, whichever one you like better. Number 14, page 412, number 44, the sine of the inverse tangent of negative radical 3. When you're doing these types of problems, I would love to tell you the answer is as simple as just shoving it in your calculator and writing down the decimal, but it's not. First of all, you need to remember that both sine and tangent have a restriction in the calculator. They're only going to give you answers between negative pi over 2 and positive pi over 2. That means you're going to get a first quadrant or a fourth quadrant answer. You have to first determine what the inverse tangent of negative radical 3 is. And if the graphing calculator gives you a decimal, you're going to have to do it the old-fashioned way. The tangent of what answer is going to give you negative square root of 3? Well, first of all, since the answer is negative, it's got to be in quadrant 4. And if it's got to be in quadrant 4, do this. this is negative square root of 3, this is 1, and the hypotenuse has to be, let's see, 1 squared plus negative square root of 3 squared equals the hypotenuse squared, 1 plus positive 3 is equal to r squared, so r is going to be 2. So the sine of this angle, whatever this angle, it doesn't even matter if you know what this angle is. The sine of this angle is going to be negative square root of 3 over 2. And I did it by drawing a picture. You could have done it by determining the angle. If you had done this in your calculator, you want to make sure your calculator's in degree mode. The calculator will tell you the answer is negative 60 degrees, which is negative pi over 3. And then the sine of negative 60 degrees, well, the sine of 60 degrees is square root of 3 over 2. But since the angle is actually in quadrant 4, you have to make the answer negative. The last problem, review, number 15, is page 420, number 8. In number 8, they want you to determine the amplitude, period, and frequency of this simple harmonic motion, and then they want you to sketch a graph of the displacement of the object over one complete period. Well, let's start with the easy part. The amplitude is 3/2. The period is going to be 2 pi over 0.2. Now, if you remember that 0.2 is the same as 2/10 or 1/5, you'll be able to figure out that this is actually 10 pi. And the frequency is the reciprocal of that. It's 1 over 10 pi. Or if you want to tell me it's decimal equivalent and tell me it's 0.0318, I guess that's okay. But I think it's easier to just write 1 over 10 pi. All right, now we have to draw one period of the graph. But I want you to notice there's a phase shift. So the phase shift, 0.2t plus 1.4 equals 0. 0.2t is equal to negative 1.4. So t is equal to negative 7. So that's the phase shift. You're going 7 to the left. Well, in order to figure out the interval on which I'm going to do my one cycle, remember it always starts at your phase shift, and the second part is your phase shift plus the period. Well, that you probably want to turn into a decimal. It's going to be negative 7 plus 10 pi, which is about 24.42. Okay, so we're going to go graph this sine graph. And it's going to start at negative 7, and it's going to go to 24.42. To find the middle ordered pair, or not ordered pair, but the middle tick mark, you're going to add those two numbers and divide by 2. That's the average. The average is going to be 8.71. I'm probably not doing this picture justice. I should move this over just a little bit. This is probably closer to here. Then, to find the tick mark between these two, you're going to add them, divide by 2, and you get around 0.86. And then to figure out what this tick mark is, you're going to subtract these to find out what each tick mark is going up by. And I think I found out each tick mark was going up 7.86. So when you add 7.86, this one over here is 16.57, about. The amplitude was 3/2. So I'll just put positive 3/2 up top, negative 3/2 on the bottom. And last but not least, the graph is a sine function. So it's going to start here. And since it's negative 3/2, it's going to go down, middle, up, middle. And there's one cycle of the function negative 3/2 sine of 0.2t plus 1.4. And that is the end of the review.